times b, so we get 2a squared minus ab, followed by b times 2a, and b times minus b, so negative b squared. Okay, so this is the first part. Then after that, we got a minus sign. So when you have a minus sign, we must be extremely careful. We focus on this section over here, and we put brackets around it. So 3b times a, we get 3ab. 3b times minus b, we get negative 3b squared. Okay, so we have this. Alright, so because of the brackets, we now need to open that up. So over here, I simplify it, minus ab plus 2ab, I get plus ab minus b squared. This will become minus 3ab plus 3b squared. So some of you lost marks due to this plus over here. Okay, then now we simplify our working. 2a squared plus ab minus 3ab, we get minus 2ab, then plus 2b squared. Okay, so we leave our answer as this. Right, so whenever we are asked to expand, final answer should not have any brackets anymore. When we are asked to factorize, your final answer should have brackets. Okay? Then for question 5, I thought that part A was supposed to be a giveaway. Unfortunately, not all got it correct. Okay, so it says that a marine fish exhibition is held at the Singapore Expo. The entrance fees for 5 adults and 6 children are $70, while the entrance fees for 4 adults and 7 children are $67. So question says that the cost of adult ticket is actually X dollars and child ticket is actually Y dollars. Right? So from the very first sentence that says that there are 5 adults and 6 children, then their total cost for the tickets is 70. So 5 times of adult plus 6 times of children, you will get 70. So this is one equation that you can get. Alright? Then after that, in the second part, it says 4 adults plus 7 children, and you get 67. Okay? When you form an equation, it is not necessary for you to put in the dollar sign. Alright? So you just leave it this way. So that's the answer for part A. Okay? Unfortunately, there are some of you, or rather quite a number of you in fact, okay? Your answer for part A is extremely long, okay? Such that you're not answering the question. The question in part A asks, given all this, okay, form 2 equations in terms of x and y to represent this information. The instruction in part A is only asking you to form 2 equations. Okay, form 2 equations only. Alright? It is not asking you to solve the equation yet. Because in part B, then it asks you to find the total amount that a family of 3 adults and 5 children need to pay. So in order to find that, then we need to solve. So this is the working that you should be having for part A. Part B, then we start to solve. Okay, so we had our equation 1 and equation 2. We will solve by elimination. So in equation 1, I can multiply by 4. And I will have this. Then in equation 2, I'll multiply by 5. Such that I have my equation 3 and equation 4. Then now I see that I have 20x that is in common in both equation 3 and 4. I will do my elimination. Okay, I'll continue here. Equation 3 minus equation 4, that will be 20x plus 24y minus 20x plus 35y equals to 280 minus 335. Okay, simplifying this, I first open up the brackets. Minus and plus give a equals to 8. So therefore, total amount will be 3 times of adults, so 3 times 8, plus 5 children, so 5 times 5, that will be 49. Okay, so answer is $49. Generally, I do recognize that many of you have the skill in terms of solving simultaneous equations, just that your working, okay, is not placed correctly. And I thought that it should be obvious to you that in part A, they didn't give you a lot of space, alright? So how can they be expecting such long working while giving you such little space? Okay, so therefore, those that wrote all this process into part A, I deducted 1 mark under presentation. Okay? Any questions? Alright? If no questions, please ensure that you continue to file your test paper into your next file. Now let's take out your notebook, sorry. Okay. And we'll move on to chapter 8 today. Quadrilaterals and polygons, okay, which requires some recap of certain things that we did in lower set, in set 1, okay. So, the front page, okay, the first page itself, okay, is the angle properties of triangles. So, let me write down first. Okay, so angle properties of triangles. Okay, what do you recall? Nicole, what do you recall? Angle properties of triangles. Sorry? Nicole, I'd like you to move to the front here. For all my maths lesson, I'd like you to sit here. Okay, maybe not, just sit at the G's table. After every math lesson, you will clean P.J.'s table. Yes. What do you recall of angle properties of triangles? Yes. You see the notes? Okay, we have our angle sum of triangle. Alright, so in a triangle itself, let's say this is a triangle ABC, and the angle set ABC, we know that A plus B plus C will be 180 degrees. Okay, another one that is less commonly used, alright, is our exterior angle of triangle. So if I label this angle over here D, for example, okay, A plus B will be equals to D. Okay, so A plus B plus C is 180, and A plus B is equals to D. That's your exterior angle of triangle. So there are some short forms that we have learned when we are in Set 1 also, right? Next, when we look at quadrilateral, okay, so a quadrilateral essentially is a four-sided figure. We have in this case A, B, C, D. Okay, then after that, the corners over here is what we call vertices. Okay, so in singular it is a vertex. Alright, so all these corners here, these points, okay, a singular word is vertex. Okay, so if there are more than one, plural is vertices. Okay, so there are four vertices, four sides, and also four interior angles. Interior angles refer to whatever that's inside the quadrilateral itself. Okay. Then after that, we also have a diagonal going across, right? And then we need to take note of how a quadrilateral is being named. Okay, when I say a quadrilateral A, B, C, D, okay, we will have it either in a clockwise manner or an anti-clockwise manner. In my case over here, I'm having it in an anti-clockwise manner. Okay, because sometimes diagrams are not given. Right, and we need to actually draw our own diagram for us to understand the question itself. So therefore, we will then need to know, okay, how our corners will be like. It doesn't matter where we start. As long as it goes in the clockwise manner or anti-clockwise manner, will be good enough. Okay? So in a quadrilateral, right, okay, because we see that if I draw a diagonal over here, okay, and I will end up getting two triangles. We agreed that in a triangle itself, the sum of the angles is 180 degrees. If I have two triangles forming up for me a quadrilateral, this will naturally tell me that the sum of the angles in the quadrilateral will have to be 360 degrees. Okay. Other things that we have learned when we are in Set 1, okay, we have also learned angles formed by two parallel lines. So mainly there are three different types. We got one that is corresponding angles, parallel lines. Okay, another one is the alternate angles, parallel lines, and lastly, we have interior angles, parallel lines. Okay, so what this means is that if I have a diagram where I have one pair of parallel lines and another line cutting across, okay, corresponding angles would mean, for example, in the corner itself, okay, so if I have A and B over here, okay, sorry, in the diagram we had W here, right, we see that A equals to W. So, for example, A equals to W. Right? We can also say that D is equals to Z, B is equals to X, C equals to Y, according to the diagram found in your notes. For alternate angle, we are looking for a Z shape. So, it is in this manner. So, in this case, if I have this angle C, C will be equals to W. And finally, for interior angles, see that this is angle D. Okay, D plus W will be 180 degrees. That is how interior angles refer to. big table telling you all the different types of diagram. All the different types of four-sided figure, or rather different types of quadrilaterals. Erase all this out. All these properties that you find on page 2 is very important. We will look at the application of it later on. So in the rectangle itself, right? Sorry, before I go into rectangle, I need you to be able to recognize that under all these diagrams here, Regarding what is a perpendicular bisector, we will cover more about that when we arrive at the geometrical construction chapter, which is the last chapter that we will cover for this year. Okay? So longer diagonal is a perpendicular bisector of shorter diagonal. Can see? It is a test of the spelling and your dictation. Alright, next one. Okay, let's go back to rectangles. So for rectangles, surely we know all four angles are right angles. Okay, diagonals are going to be equal in length. Okay, so only in a rectangle and a square that the diagonals are equal in length. Okay, the diagonals bisect each other, meaning to say that the length AE over here is the same length as EC. DE over here is equals to BE. So it's written in words over here already. Okay? So it's a matter of translating here. Right? Whereas in the square itself, diagonals are equal in length also. Diagonals bisect each other at right angles, so only for square, where we are able to see that in between here we get a 90 degrees, whereas for rectangle we don't. Okay, then diagonals bisect each other at right angles. Sorry, your point covered. Then diagonals bisect the interior angles. Okay, so that means that this diagonal will create 45 degrees here and 45 degrees here. Okay? This is frustrating. Alright, so then for parallelogram, opposite angles are actually equal. Alright, that means that angle ADC, this angle here, is equal to this angle. Whereas this angle here is equal to this angle. Right? Everything is actually written in words already. It's a matter of whether you can read and just translate the diagram. I've already written it out in words. Okay? So when I want to talk about opposite angles are being equal, right? Okay? The reason to write here for parallelogram are opposite angles of parallelogram. Okay, so the short form for opposite angles are equal will be opposite angles of parallelogram. Okay, diagonals bisect each other, same as before. Okay, we got AE equals to EC and DE equals to BE. So written over here. For this, the reason will be diagonals of parallelogram. Okay, so this is for parallelogram. Alright, moving on to rhombus. For rhombus, okay, opposite angles are equal, so same thing as your parallelogram. We see that this angle here is equals to this angle, and this angle here is equals to this angle. Then diagonals bisect each other at right angles, so similar to the square, and diagonals bisect interior angles, meaning to say that this and this are equal. Okay? To be very honest, you did not actually copy exactly how I draw it. You just have to read this. I'm sure you have the intellectual ability to read what is the angle and then transfer the information here. Why did I not put this into a diagram? Because it's too much. Then otherwise you will distract everything over here. That's very messy. So So you just got to read this information here. Okay? Then opposite angles are equal. For rhombus, we will say as opposite angles of rhombus. So it's the same thing as parallelogram, just that instead of parallelogram, we write rhombus. If I'm using any diagonal property, I will say diagonals of what? Of rhombus. Because we're talking about rhombus, right? Okay, so those are the short forms. Right? Yes. Yes. Example 1 now, right? It says that the figure below shows a rectangle ABCD. E lies on AB such that angle ADE is 51 and this angle here is 68 degrees. So in part I want to find out what is the angle of AED. You may notice that sometimes we write the angles in this manner. Okay, so you need to be able to read and understand what the question is saying. So angle AED refers to this angle here. How do you think we can find it? Yes, Brian.
180 minus 90.
Yeah. Okay, so angle AED, right, it's 180 minus 90 degrees minus 51 degrees. Right? How do I know this? Because this is a rectangle. Angle DAE over here will have to be 90 degrees, right? Okay, and then we take 180 minus this 2. Due to what reason? What would the reason be, Ben? Why are we doing 180 minus 90 minus 51? Sorry? So what is the short form that I will write? Come on, it's on page 1. I already printed it for you. Sorry? Angle sum of triangle. Alright, next one, part 2. We want to find out what is angle CED. So CED refers to this. Okay? So how do we find out what is angle CED? Geraldine, what do you think? There's 2 steps to this only.
Find CDE.
Find what?
Find angle CDE.
Angle CDE, which is
90 minus 51.
yes, 90 degrees minus 51 degrees, we get 29 degrees. And angle CED is
180 minus 68 minus 70.
yep. And the reason is so angle CED we take 180 minus 68 minus 39 because angle sum of triangle, yes. Right? Next we look at example 2. Okay, of course my working over here is not limited to just this. You may want to do it in a different manner. That's also possible. Okay, but the answer will still eventually get you 73 degrees. Right? In example angle as well. And then after that, we want to find angle BEC and CDE. Okay, so angle BEC refers to this angle here. How do you think we can go about finding it? Maliki, what do you think? We may need to make use of some properties of a rectangle. Can you call that boy up? Yes. Minus 63. Okay, but I need you to tell me why is this 63 degrees? So why? Because the question never say what. Yes, Glenn? Okay, why is triangle CEB is an isosceles triangle? So why is that so? Why must CE be equal to BE? Okay, so let us refer back to our rectangle information. Okay, so in the very first row, when we look at rectangles, it says that under diagonals are equal in length. Okay, that's the first point. Diagonals being equal in length would mean that the length of BD is equal to AC. So that's what the first point actually means. Second point says that diagonals bisect each other. What that means is that BD, it cuts AC into two equal parts. That means this length here is equal to this length here. Okay? Likewise, AC, okay, actually cuts BD into two equal parts. Right? That's what the second point actually means. But because the diagonals are equal in length to each other, AC and BD are equal. If they are supposed to be half of each other, that means everything has got to be equal in length. Do you understand? Okay, so in a rectangle itself, right, the diagonals, okay, when I have a center point over here, everything inside are equal in length. So that is why CE is equals to BE. And how we actually explain that into our reasoning is that diagonals of rectangle bisect each other. Okay, that's why triangle CEB will be an isosceles triangle, and therefore we can say angle BEC will be 180 minus 63 minus 63, and this is due to angle sum of triangle. Okay. So every single step here would be necessary in your explanation. So Zhang, please stand outside. Yes.
You mean that angle CED equal to
Angle CED
equal to angle BEA.
BEA. These two angles, it will definitely be what? Because as soon as you go across, these two angles, vertically opposite angles happen. Okay, so it's not a property of rectangles at all. As any two lines, that will happen. Right? So now let's look at angle CDE that I want to find here. Okay. How would you go about finding it? We already know that this is 55 44 degrees. Okay? What would you do then, Wheeler? 90 degree minus 63 degree, that finds out what angle? Which angle are you looking for? Please name it. CDE. CDE over here is 90 degree minus 63 degree. How do you know down here 63? Just because down here got 63, down here must have 63, man. Sorry? Just because they're opposite each other, they must be the same. I stand opposite you, I don't look like you. Unless it's a mirror, right? Yeah. Just because they're opposite does not always mean them having to be equal. So that's not that's not logical. Can I provide something more rigorous in terms of like the explanation? Don't skip steps. I'm not asking for immediate answers. Yes, Jing.
Maybe like we can find angle ECD.
Angle what?
ECD.
ECD. So Wheeler, do you agree? Jing suggests finding angle ECD. Okay? ECD will be 90 degrees minus 63 degrees. That will give us 27 degrees. Alright? Then after that, so what? So Wheeler, continue and complete the question. CDE equals to 27 degrees. Okay? But why? Because DE and EC both are lines. Yeah. Equal. Okay. So that makes triangle CDE an isosceles triangle. Therefore, we use base angles of isosceles triangle. Okay. Yes. Sorry? I can't hear you. Yes. Any questions? Or anybody wants to suggest something else? Anna? Now let's look at example 3. Okay, so in example 3, right, we got a parallelogram. Right, so the information is given there. It is said that angle ABC is 9x degrees. Right, in part I, we want to find the value of x. And part 2, we want to find angle DCE. So ABC refers to this angle here. And this is 9x degrees. How do you think we can find out or form an equation to know what is x? Now this is a parallelogram. Okay, so let's refer to our table, okay, for the rule of parallelogram. Right? So what can I say about this 9x degrees over here. What will it be equals to? What will it be equals to, Kaishan? Sorry? Why is it equals to 180 degrees? Sorry? I can't hear you. So what if it's a parallelogram? What is the property that we apply? So what is the reason that I should write? Okay, I will write opposite angles of parallelogram. Right? Then I can find out what is the value of x by making 108 divided by 9. So x will be 12. Okay. Next in part 2, we want to find angle DCE, which is this angle here. What do you think we can do then? Janice, what do you think? Sorry? Okay, why are we doing that? What triangle is there here? Okay, interior angles. Yes, very good. But I don't think you know why is it interior angles. Okay, so answer will be 34 degrees. Interior angles, parallel lines. Okay, so why is that happening? It is because I know that we have parallel lines over here. Agree? Okay, so because we have parallel lines, in between, inside the parallel lines, okay, this angle and this angle here must add up to be 180 due to interior angles parallel lines. Okay, so therefore when I take 180 minus 108, I will be able to find out what is angle BCD. Then I minus away 38, I will find out what is angle DCE. Understand? So I take 180 minus 108, I can find this. Then I minus away 38 here. Then I can find the angle that I want.
The bottom that one is 108.
Why this one is 108?
No, DC.
Why is DCE?
DCB.
B, is it?
DCB.
DCB,
Is it C is 108?
No, this angle here, let me just rewrite this. Angle BCD is 180 minus 108 degrees because of interior angles, parallel lines. Okay? Correct? Understand? Then after that, we have angle DCE to be 72 degrees minus 38 degrees. It will be 34 degrees. Okay? Any questions? Yep. Sorry? Yeah, Geraldine, any problems? we are given the expressions for some angles. So since this is a parallelogram, let's form an equation. Okay? Form an equation in order to find out what is x and y. That means that somehow two of it are equal. But you need to tell me why. Okay? So can you give me one option? Chelsea. One pair that is equal to each other and why? 5x plus 6. Okay, maybe they are not entirely equal, but they are related. Sorry. 5x plus 6 and 2x plus 13. They are equal, is it? I don't think the diagram looks like they're equal to you. Okay, so 2x plus 13 equals to y plus 17. Why? Because opposite angles of parallelogram. Yes. But as we write this down, I want you to notice there's an x here and there's a y here. We cannot solve. Because got x and y, got two unknowns. Right? So we need something else. Another piece of information. We need to relate two other angles, okay, in order to find out what is x. How can we do that? Yes, Declan. 5x plus 16. Alright, so 5x plus 6 plus 2x plus 13 equals to 180, and the reason is it is not a parallelogram property. Something else we learned is that one. We just used it only. Yes, very good. Interior angles parallel lines. Okay, so because they are in between parallel lines, these two will add up to be 180 degrees. Okay, so we can solve this one. We get 7x plus 19. Okay, we get, sorry, I think like 161 degrees. So x will be equals to 23. Alright, then now we need to find y, and we can do so by putting it back into the first one. Okay, so 2x, where x is 23, plus 13 equals to y plus 17. Okay, then we will solve, and this will be 59. So y is equals to 42. Right? Okay. Due to the time factor, okay, I need you to do the workbook questions at home, right, and get yourself ready for the next math lesson. Okay, so the next time we see each other will be next week on Monday, right? So please do workbook, page 87 to 89. Okay, question 1, 2, 3, 4, and 6. 5 don't need to do because it is already found in your example 3. It's the same thing in example 3. Right, so just do 1, 2, 3, 4, and 6. Okay, so due next Monday. Right, that's all. Thank you, everyone.